name is Hafiezah binti Hairul Sham with the metric numbers of 281187. Let's start with the introduction. Mathematics, an integral assign number to function in a way that describe displacement, area, volume and other concepts that arise by combining infinitesimal data. The process of finding integral is called integration. Along with differentiation, integration is a fundamental, essential operation of calculus and serves as a tool to solve problems in mathematics and physics that involve the area of arbitrary shape, the length of a curve, and the volume of a solid, among others. Major advance in integration came in the 7th century with the independent discovery of the fundamental theorem of calculus by William Leibniz and Isaac Newton. The theorem demonstrates a connection between integration and differentiation. This connection, combined with the comparative ease of the differentiation, can be exploited to calculate integrals. In particular, the fundamental theorem of calculus allows one to solve a much broader class of problems.
My name is Aznurul Aishah with matrix number 280526. Today, I am going to explain about key concept. Integration is used in economics and business to find total cost function. The marginal cost function is a derivative of total cost function. Thus, total cost function is the integral with respect to x of the marginal cost function. Total cost when x equals to 0, C0 equals to k, where k is the fixed cost. Integration is applied in economics and business with purpose to find total revenue function. Marginal revenue function is the derivative of the total revenue. Thus, the total revenue function is the integral with respect to x of the marginal revenue function. When x equals to 0, there is no revenue, or R0 equals to 0, thus k equals to 0. Next, integration is applied in economics and business to find consumer surplus. Look at the graph below and suppose that P is a price that consumer willing to pay for a quantity of a particular goods. The demand curve can be written as P equals to dx. If market price is P1 and corresponding market demand is Q1, then consumers who would be willing to pay more than this market price gain from the fact that the price is only P1. The total consumer gain is represented by area below the demand curve and above the line P equals to P1, and it is known as consumer surplus. Thus, the formula for consumer surplus is stated below. Last but not least, integration is applied in economics and business to find producer surplus. Look at the graph below and suppose that the price P is a price that the producer willing to charge for a quantity of a particular goods is governed by the supply curve P equals to Sx. If market price is P1 and corresponding market supply is Q1, then those producers who would be willing to supply the commodity below this market price gain from the fact that the price is only P1. The total consumer gain is represented by area below the supply curve and below the line P equals to P1, and it is called producer surplus. Thus, the formula for producer surplus is stated below. That's all from me. Thank you.
My name is Nur Safa Afifah binti Rafizi, metric number 280749. I will continue with the method of integration that we use to apply in economics. The methods that we use can be found at Chapter 2, Techniques of Integration in Calculus 2. In our case later, we will use integration using substitution to find the cost function from marginal cost function, while integration by part will be used to find revenue function from marginal revenue function. Integration by substitution, also known as U substitution or change of variables, is a method for evaluating integrals. First, have to choose a new variable, determine the value or terms that need to be substituted, make the substitution, integrate resulting integral, and lastly remember to return the variable to the initial variable. Integration by part is a process that finds the integral of a product of functions in terms of the integral of the product of their derivative and antiderivative. It's one of the ways to solve integration problems. The formula for integration by part often makes it possible to reduce a complicated integral involving a product to a simpler integral. Next, we still use basic integration such as integration of 1 over x is ln absolute x to solve the cases of consumer surplus and producer surplus. This is about area under the curve. To find consumer surplus, we have to calculate area below the demand function. Meanwhile, to find the producer surplus, we have to calculate area below the supply function. That's all from me about the method we use. I will pass to my others members.
My name is Jie Rou with my metric number 280580. I'm going to explain the example of how integration applied in economics. So let's see the question 1a. The question given, the marginal cost function is c prime x equals to 6x squared plus 24x over x plus 2 squared with 6,000 ringgit of fixed cost incurred, and then we are required to find the total cost function cx. So as we know that the marginal cost function is the derivative of total cost function. So now we have to find the total cost function. We have to integrate the marginal cost function. So let's see how the integration works. First, we can expand the x plus 2 squared, become x squared plus 4x plus 4. And then at this case, we figure out that we can use a long division. And then this is the result of our long division, 1 minus 4 over x squared plus 4x plus 4. And then the integration rule tells us that we can separate this into two terms. This is the first term and then this is the second term. So this is the basic integration, so we are focusing more at this. Okay, so at this case we can use the substitution method, where let u equals to x plus 2 and then we differentiate u with respect to x and then we get du equals to dx. And then we will sub u inside this x plus 2. Okay, the next step is like this. So we can take out the coefficient of 4 and then 4 times 6 will be 24. So here will be 1 over u squared respect to du because dx equals du. Okay, this is the result of the integration, negative 1 per u. Okay, and then the negative become positive. And then we have to substitute the u to the initial variable x, which means u equals to x plus 2. And then we are not done yet with our total cost function. We have to find out the constant c. Okay, when fixed cost incurred, x equals to 0 because there is no production. When x equals to 0, there is no production, but there is still 6,000 of the fixed cost is charged. So cx equals to 6,000, hence c0 equals to 6,000. So we sub the equation just now with this one, we start with 0, and then we will get the c is equals to 5,988. Lastly, the total cost function is 6x plus 24 over x plus 2 plus 5,988. Okay, the next question 1b is about the revenue function. So we are given marginal revenue function r prime x equals to negative 100 e raised to the negative x times x minus 1. And then we are required to find the total revenue function. So it is the same concept. When we have to find the revenue function, we have to integrate marginal revenue function. Okay, let's see. So at here we can expand first. So this is our expansion form of the previous one. Okay, let's see. The integration rule tells us that we can separate down into two terms. So this is the first term and this is second terms. The second term will be the easy integration. So we focus on this. Okay, we can use the integration by parts, and then this is the general formula of integration by parts. So we let u equals to negative 100x, and then differentiate u with respect to x, we'll get negative 100 dx, and then dv will be e raised to the negative x dx, and then integrate it, we'll get v equals to negative e raised to negative x. So uv minus v du. Okay, this is the integration by parts functioning here. And then this copy back the previous one because we still haven't integrate this. So just copy back. And then this one, negative become positive. Negative become positive again. We get 100 e raised to negative x dx plus the previous one, we copy back again. Okay, so here the basic integration works here. We get the result is the coefficients remain 100 with negative e raised to the negative x plus 100 negative e raised to the negative x. And we have a constant k here. We will figure it out later what is the value of k. So negative, positive, and then positive, negative, we get negative, and then these two is cancelled, and then we get the 100x e raised to the negative x plus k. Okay, so when there is no production, x equals to 0, there is no revenue. Hence, R0 equals to 0. And then we sub back the equation just now. Okay, we sub back and then we get k equals to 0, which means that the total revenue function Rx is equal to 100x exponent 100x e raised to the negative x. That's all. So I will pass to Kok H'ng for the next question. Thank you.
Okay, for question 2, the question said that under perfect competition for commodity, the demand and the supply law are dx equal to x over x plus 1 minus 2 and xx equal to x plus 3 over 2 respectively. So we need to find the consumer surplus and the producer surplus. So at the market equilibrium or under the perfect competition, dx equal to sx. So we put the function of dx and sx inside, and then we get 8 over x plus 1 minus 2 equal to x plus 3 over 2. Since we need to let the denominator same, so we times x plus 1 inside. And then we will get 6 minus 2x over x plus 1 equal to x plus 3 over 2. And then we cross multiply. We will get 12 minus 4x equal to x plus 1 times x plus 3. Then we will get x squared plus 8x minus equal to 0. And then we will get x equal to 1 and x equal to negative 9. Since x cannot be negatives, therefore x equal to 1. Okay. Next. And then we need to find y0. Y0 equal to x plus 3 over 2. Since just now we know that the x equal to 1, so we sub 1 inside the x. And then we'll get y0 equal to 2. And x0, y0 equal to 1 times 2 equal to 2. Okay, now we can find the consumer surplus. And the function for consumer surplus is integrate from 0 to x dx minus x0, y0. So we integrate from 0 to 1, x over x plus 1 minus 2 dx minus 2. And then after integrate, we'll get x ln x plus 1 minus 2x minus 2x. And then we substitute 1 and 0 inside, we'll get x ln 2 minus 2 minus x ln 1 minus 0 minus 2. Then we'll get x ln 2 minus 2 minus 2. And then the final, we get 1.454 units for the consumer surplus. And for the producer surplus, we know that the producer surplus function is x0 y0 minus integrate from 0 to x dx. And then we know that x0 y0 equal to 2. And then we minus from integrate from 0 to 1 x plus 3 over 2 dx. And then after integrate, we'll get 2 minus 1 over 2 times x squared over 2 plus 3x. Okay, then we substitute 1 and 0 inside the function, and we get 2 minus 1 over 2 times 1 over 2 plus 3 minus 2 over 0 over 2 plus 3 times 0. And then we get the producer surplus is 1 over 4 units. And this graph is we find from the Desmos website. As you see, the red line is the demand function, which is 8 over x plus 1 minus 2, and the blue line is supply function, which is x plus 3 over 2. And then the area under this is consumer surplus, and the area of this is producer surplus. Okay, that's all for me. Thank you.
Integration can dramatically increase productivity, reduce waste time due to manual process and IT resources, and can help your business skills for future growth. When you are considering purchasing new software for your business, it is worth the extra time and cost on the front end to ensure that the new software integrates with your current system. If you are using a bookkeeping system, connecting to your payroll and time and attendance software decrease manually data entry and helps to ensure accurate employee data and payroll. To relate with the topic of integration in academic that we choose is, it is widely used in academic. It is play an important role in determining the output in the marketplace in order to achieve maximum profit, and it can be minimize the productions of costs. Marginal and total revenue also we can get through integration. If the marginal profit functions is given, the total profit can also be obtained by integrating the marginal profit function. So that's all from us. Thank you.